Imagine you are standing on a beach in South Texas. It's a Tuesday evening. The Gulf of Mexico is calm behind you. The sun is low, painting everything gold and orange. The air smells like salt and something else, fuel, metal, heat. And in front of you, about 3 miles away, something is standing on the horizon that doesn't look like it belongs on Earth. It is taller than a 40-story building. It is wider than a house. It is sitting on a pad surrounded by fire suppression systems and steel arms the size of skyscrapers. And in about 60 seconds, it is going to ignite 33 engines simultaneously, releasing more energy in a single moment than the atomic bomb dropped on Hiroshima. You feel the ground under your feet. You think it's solid. It isn't. Not for long. Before we go any further, if you are new here, hit subscribe right now, because this channel covers the moments that change civilization. And May 19th, 2026 is one of those moments. This is not a drill. This is not a test. This is the most powerful machine humanity has ever built, completely rebuilt from scratch, about to leave the ground for the first time. And if you think you know what Starship is, you don't. Not anymore. The old Starship was already terrifying. Version 2 was already the biggest rocket ever flown. It already shook buildings miles away when it launched. It already punched a hole through the atmosphere like a god throwing a spear at the sky. And people watched it, amazed, thinking, this is the pinnacle. This is the top. There is nothing beyond this. But here's the problem. SpaceX looked at that pinnacle and said it wasn't enough. They didn't upgrade Starship. They didn't patch it. They didn't iterate. They went back to the drawing board on almost every single system. The engines, the booster, the upper stage, the launch pad, the avionics, the heat shield, the fuel systems, and rebuilt it. From the ground up, the machine you thought you knew is gone. What's standing on Pad 2 tonight is something new, something that has never flown before, something that has never been tested in the only environment that truly matters, space. And that, right there, is where the fear begins. Let's talk about size, because your brain needs a moment to understand what you're actually looking at. Starship V3 is 5 feet taller than its predecessor. That doesn't sound like much until you realize that 5 feet on a rocket of this scale means extra propellant volume, extra structural mass, extra fuel burning capability that compounds into something almost incomprehensible. V3 can carry over 100 metric tons to low Earth orbit and bring the vehicle back, reusable, intact, ready to fly again. To put that in context, the Saturn V, the rocket that sent humans to the moon and is still worshipped by engineers as a miracle of the 20th century, carried about 130 tons to orbit. But it was expendable. It was thrown away after one use. Starship is designed to do it over and over again. 100 tons. Reusable. Over and over. You could put a school bus full of people, their luggage, 6 months of food, all their equipment, and a car into orbit, and then land the rocket and do it again next week. That is what this machine is designed to do. And on May 19th, it is doing it for the very first time. But it gets worse. 33 engines ignite simultaneously at liftoff. 33. Each one is a Raptor 3, the newest, most powerful, most stripped-down version SpaceX has ever built. Sea-level variants now push 551,000 pounds of force each. Do the math? 33 engines, each producing over 250,000 kilograms of thrust, all firing at the exact same moment. The total liftoff thrust exceeds 18 million pounds. 18 million. For comparison, the Space Shuttle produced about 7 million pounds of thrust at liftoff. You could stack 2.5 Space Shuttles on top of each other and still not match what Starship V3 produces in its first second off the pad. The ground doesn't just shake, the ground becomes part of the event. But let's talk about what's inside those engines, because this is where it gets unsettling in a way most people don't discuss. The Raptor 3 is not just more powerful than its predecessor, it is fundamentally different in its architecture. SpaceX removed the external gas generator. They eliminated the individual engine shrouds. They integrated the sensors and controllers directly into the engine body and covered them with thermal protection. The result is an engine that looks almost naked, clean, almost alien, stripped of all the external complexity that used to make it look like a machine you could understand. Each engine lost over 100 kilograms in the process. Multiply that by 33 engines across both vehicles, and you get roughly 1 ton of mass savings per engine in vehicle-level reduction. They made the most powerful rocket engines ever built, lighter, faster, and more capable at the same time. Engineers will tell you that's an achievement. And it is. But there's a darker way to read that story. Every simplification, every removal of a redundant system, every decision to streamline, those are bets. Bets that the remaining systems won't fail. And on a first flight, with a vehicle that has never flown before, with engines that have never experienced the actual thermal and acoustic environment of an integrated launch, those bets haven't been tested. Not really. Static fires at McGregor, Texas are not the same as 33 engines igniting together under a fully fueled 5,000 metric ton rocket. Nothing is the same as that. Nothing can simulate that. The only way to know if it works is to do it. And this is where things change. Now look up at the booster, the Super Heavy, the first stage. On previous versions of Starship, the Super Heavy had 4 grid fins, those lattice-like structures that stick out from the body of the rocket and help it steer as it falls back to Earth. 4 fins. On V3, there are 3, but each one is 50% larger, 50% stronger, repositioned lower on the body of the rocket to reduce heat exposure during the moment when the upper stage engines ignite above the booster, a moment called hot staging, where Starship's 6 Raptor engines light up while the 2 vehicles are still physically connected, blasting fire directly down onto the top of the booster. Think about that. The booster's own fuel tank is exposed during that moment. The forward dome of the booster, the top of a tank filled with hundreds of tons of liquid methane, is directly in the path of Raptor engine exhaust. SpaceX says a non-structural steel layer and internal tank pressure protect it. They replaced the old single-use interstage with a permanent integrated hot stage that stays attached to the booster. They say the actuators retract after separation to shield themselves from the blast. They say. But here's the problem. This integrated hot stage has never flown on a V3 vehicle before. The interaction between the new booster geometry, the new fin positions, the new fuel systems, and the heat of hot staging under real flight conditions. That combination has never happened. Every simulation in the world cannot replace the moment it actually occurs at 30 kilometers altitude, moving at a speed that would take you from New York to Los Angeles in about 4 minutes. And that's not even the worst part. Let's talk about what's happening inside the upper stage as it climbs away from Earth. Starship's ship, the upper stage, has been completely rebuilt. The propellant tank is larger. The aft end has been entirely rerouted. Fluid systems, electrical systems, all of it redesigned to support a new way of starting the Raptor engines. The old flap actuation system used 2 actuators per flap. The new one uses a single actuator with 3 motors. Less mass, more redundancy, in theory, but single-point systems are gambles. Every engineer knows that. You remove one actuator, you save mass, you reduce cost, and you concentrate all your faith in a different place. Then there are the 4 docking drogues. SpaceX added 4 docking ports to the leeward side of ship. Small structural attachment points designed for the future. For the day when 2 starships find each other in orbit, connect, and transfer propellant from one to the other. This is called orbital refueling, and it is not optional if humanity wants to reach the Moon and Mars. A starship can carry enough fuel to get to low Earth orbit. It cannot carry enough to get to the Moon and back. You need to refuel in space, like a mid-air refueling tanker, except in the vacuum of space, with cryogenic liquid methane and liquid oxygen at temperatures close to absolute zero in microgravity. with no margin for error. The drogues on Flight 12 won't be used. This flight won't attempt a docking. But their presence on the vehicle is a statement. It is SpaceX saying, "We are no longer building a rocket. We are building infrastructure. We are building the scaffolding of a civilization that doesn't live here." But here's something that quietly unsettles every engineer who studies it. The heat shield. You are re-entering the atmosphere at 25 times the speed of sound. The air in front of you cannot move out of the way fast enough. It compresses, it heats, not because of friction, because of compression. The plasma that forms around the vehicle during re-entry reaches temperatures exceeding 1,600 degrees Celsius. The tiles on the heat shield are the only thing standing between the vehicle and vaporization. On previous Starship flights, tiles fell off. Multiple tiles. Engineers watched them go, studied the damage, and learned. On Flight 12, SpaceX has redesigned the tile geometry and the attachment clips based on everything they've learned. The heat shield is the most complete it has ever been. Only one tile is missing at liftoff, and it was removed on purpose. To learn, to measure what happens to the tiles next to a gap when the plasma finds its way in. To understand the aerodynamic loads that propagate through a shield with a single missing piece. 2 of the 22 dummy Starlink satellites on board will photograph the heat shield from space during flight. In real time, live footage of Starship looking at its own skin as it prepares to fall back into the atmosphere. That image, a spacecraft staring at its own wounds before re-entry, should send a chill through you. Because it means SpaceX doesn't fully know what the heat shield looks like mid-flight either. Nobody does. This is how you find out. And this is where it gets existential. The vehicle has 50 onboard cameras, 60 custom avionics units delivering 9 megawatts of peak power. The entire data stream is transmitted through 480 megabytes per second of redundant Starlink connectivity. A rocket connected to a satellite constellation it is itself designed to deploy, sending real-time telemetry of its own first flight. And somewhere in that data stream, if something goes wrong, the last images the world sees will be the inside of a fireball 60 kilometers above the Indian Ocean. That is not a hypothetical. That is a planned contingency. The booster will not be caught by the tower arms on this flight. SpaceX confirmed it. After all the incredible catches on Flights 5 through 11, the mechanical arms reaching out and grabbing a falling skyscraper out of the sky, Flight 12 will let the booster fall into the Gulf of Mexico. Because this is a completely redesigned vehicle. Because the new catch point positions on the fins need to be validated in flight before anyone trusts them to a precision catch. Because even SpaceX understands that you don't use a new hand to catch a falling building until you've practiced the motion. The booster, after 7 minutes of flight, will splash down in the Gulf, and the ship, 65 minutes after liftoff, will come down somewhere over the Indian Ocean. $1 trillion of engineering ambition surrendered to the sea. On purpose. And here is why all of this matters in a way that reaches past engineering. NASA's Artemis program is waiting for this. The plan to return humans to the moon, not just to orbit it, not just to photograph it, but to land on it, walk on it, live on it, depends on a Starship variant being proven, validated, and ready by 2028. There is no backup plan at this scale. There is no alternative vehicle that can do what Starship is designed to do for the Artemis human landing system. This flight, on May 19th, is not just a test. It is an audition. It is Starship proving to the world, and to NASA, that the most ambitious redesign in modern rocketry actually works. If it does, the path to the moon opens. And after the moon comes Mars. And after Mars comes the question humanity has never had to answer before. What do we do when we are no longer a single-planet species? What are we then? What are the rules? Whose laws apply? Who are we when Earth is just a blue dot in someone's rear-view mirror? Starship V3 is not a rocket. It is a door. And on May 19th, for the first time, We find out if it opens. You are still standing on that beach. The countdown is at 10 seconds. The air pressure changes. Something primal in you recognizes what is about to happen before your brain does. Your chest tightens. The ground vibrates. And then, 33 engines ignite at once, and for 4 full seconds before the sound reaches you, you watch in complete silence as the most powerful machine ever built by human hands lifts off the Earth on a column of fire. The sound arrives, and it doesn't sound like anything you've ever heard. It is not an explosion. It is deeper than that. It is a sustained physical force that passes through your ribcage and shakes something loose that you didn't know was there. It is the sound of a species deciding it is not finished yet. It is the sound of everything changing. The universe did not invite us. It did not make room for us. Every star that ever exploded, every black hole that ever formed, every gamma ray burst that ever vaporized a solar system in 6 seconds, none of it was designed with us in mind. We are an accident on a rock circling a medium-sized star in the outer arm of an unremarkable galaxy, surrounded by 400 billion other stars in this galaxy alone and 2 trillion galaxies beyond. And yet, we built something that can leave. Starship V3, May 19th, 2026. The first flight of the machine that was designed to take us to the Moon, to Mars, and eventually to places we haven't named yet. Whether it works or not, the fact that it exists is the most terrifying and the most beautiful thing about being alive right now. If this video hit you the way it hit me writing it, drop a comment below. Tell me one word that describes how you feel about humanity going multiplanetary. I read every single one, and if you want to be here when Flight 12 actually happens, subscribe and hit that bell, because we will be covering every second of it live. The door is about to open. Don't miss it.